Okay, in stoichiometry, the most basic relationship we have is a mole-mole. I'm looking at your mole-mole problems from your homework. I'm going to look at number 4 and see how that one works out for you. Basically, this is the equation you're given, and the question is, if you have 4 moles of C3H8, how many moles of oxygen are going to react with it? So the first thing, you want to do is you want to establish that you have 1 mole of that, 5 moles of this. It seems tedious, but it's frequently forgotten. So you write your mole ratios up at the top. Now, to do the conversion, we're going to use dimensional analysis. So I'm just going to do this. I'm going to write what I know in the upper left-hand corner. What I know is what they gave me, 4 moles of C3H8. What I'm trying to figure out is moles of O2. In order to move, you need to look at the chemical equation. So if I have 4 moles of C3H8, well, I only have 1 mole there. So how about let's do a conversion to say if we have 1 mole of C3H8, how many moles is it going to react with oxygen? So I have 1 mole here, I have 5 moles here. So I'm going to say that 1 mole of C3H8 is equivalent to 5 moles of O2. And when I do that, I see that I have moles of C3H8, moles of C3H8, so I can cross those out. So I used the chemical equation in order to move from moles of one substance to moles of another substance. The question is, how many moles of O2 do I have? Well, this is going to be answered because here I have moles of O2. So let's go ahead and do the math. You have 4 times 5 moles of O2 divided by 1, and I crossed out those units. So the only units I have are moles of O2, which is what I wanted to figure out. 4 times 5 divided by 1, that's 20 divided by 1, which equals 20. My units are moles of O2. So this is the answer, and I can write it up there.